Can we take that next step to classify the triangle? Algebra sandwich, right? Geometry and alphabetical geometry. If you finished the warm-up, you're welcome to move on to the package in front of you. It is a review pack to help you prepare for the test 1 week from today.
On the bottom right
How's that audio? Can you guys hear me online?
Sorry. Yeah. I didn't understand.
Okay. All right. Can I have your attention, please, to show this finished up? So again, the warm-up asked you to solve for x, then use the angle measures to classify the triangle given these angles. So we said that the angles add up to 180. When we substitute, we can solve. When we get to this stage, we say it's a quadratic, and quadratics are solved differently. Instead of putting the x's on one side and the numbers on the other, we move everything over to this side, and we're going to try to create a product, two things multiplied together to make 0. If we can do that, then we know that one of those things has to be 0. It's called the zero product property. So towards that end, we often use this idea of called a diamond, is what it's usually referred to as. What we're looking for is two numbers that multiply together to make -160, while at the same time adding together to make a +12. Now, there's an infinite number of choices, numbers that can add together to make +12, right? It could be +10 and +2, or +8 and +4, or -2 and +14. There's just too many choices. But the number of integers that multiply together to make 160 is limited. So that's where we start. We factor 160 into 160 and 1, 80 and 2, 40 and 4, 32 and 5, 20 and 8, 16 and 10. And then we say, since this product is negative, what do we know about the signs of these two numbers? Good. One has to be negative and one has to be positive. And if they're going to combine to make a positive 12, will the bigger number be positive or negative? Positive. We need this side to be positive and this side to be negative so that together they make a positive 12. In other words, we're looking for something where the difference is 12 between these two numbers. 20 and 8 fits the bill. When I put in a negative 8 and a positive 20, they multiply to make negative 160 and they add to make positive 12. Now, the idea behind this little diamond tool is that it's going to allow us to break out this expression in a slightly different way. I'm going to leave the x squared right where it is. I'm going to leave the 160 right where it is. But in the middle, I'm going to separate 12x into two different parts. I'm going to have negative 8x plus 20x. Still the same value, right? This equation and this equation are totally equivalent. Having done it this way, though, what I can do is now factor by grouping. Looking at these first two terms, what is it that's common to both x squared and negative 8x? X. So I'll pull that out. I'll factor it out to see what's left. X times x makes x squared. X times negative 8 makes negative 8x. Then I'll do the same thing for the second part here. I'm looking for what's common to both of these two. This is 20x and this is negative 160. What can I divide evenly out of both of those? 20, right? And if I do it correctly, what we'll find is that 20 times x makes 20x and 20 times negative 8 makes negative 160. What we should find is this middle thing is the same in both cases. Now, this is always a little weird for people to internalize, but now I'm looking at, just as I had two terms here, these x's were multiplied together and the 8 and the x were multiplied together, but each of those was a separate term, separated by addition and subtraction. Here, this is now one term, and this is the second term, separated by addition or subtraction. Within those two terms, what is it that's common that I can factor out? Both of them have x plus 8. So I'm going to factor that x minus 8. I'm going to factor that x minus 8 out. And what remains is x plus 20. Now, there are people who will say, can't I just have gone from the diamond directly to this, say x minus 8 and x plus 20? And the answer is yes. In this case, that shortcut would have worked. There are also people who choose to use a box method. How many of you used a box method? Yeah, same idea though, exactly. I'm still going to have the x squared here. I'm still going to have the negative 160, and I'm still going to split this 12x up into negative 8x and positive 20x. The only difference is we treat it as an area, and we say this is x times x, x times negative 8, x times positive 20, and positive 20 times negative 8 is negative 160. And that tells us then that it's x minus 8 and x plus 20. Same idea gets us here. Any questions on getting to this step? Okay, so that's the algebra. The final piece of algebra is to apply that zero product property to say that if in fact these two things multiply together to make 0, then one of them must be 0, because that's the only way they can multiply to make 0. So either x minus 8 equals 0 or x plus 20 equals 0. If x minus 8 equals 0, then x equals 8. If x plus 20 equals 0, then x equals negative 20. This tells us two answers. This is the algebra. But this was a geometry problem. So we need to go back and look at if it works. If I put negative 20 in for the measure of angle C, I'd get negative 20 squared, 400 plus 5, I'd get 405 degrees. If I put it in over here, I'd get negative 200 plus 10 is negative 190. Those don't make sense. The algebra created an extraneous solution that's not part of our world. So let's try the 8 instead. We think that the measure of angle A should then be 2 times 8 plus 5, right? It was 2x plus 5. So that's 16 plus 5, which is 21 degrees. That seems more normal. Measure of angle B was 10 times x plus 10. 80 plus 10 is 90 degrees. And then measure of angle C is equal to 8 squared plus 5, which is 64 plus 5, which is 69. That's 3 angle measures that add up to 180. That seems very reasonable. Now, the question was to classify this triangle. So when we classify the triangle, first by angles, how do we classify this triangle by angles? Which one do we look at?
90.
Yeah, the biggest one, right? We take the biggest angle, we look at it. In this case, it's a 90, so we'd call it a right triangle. The second way we're going to do it is we're going to classify it by the side lengths. We don't have any side lengths, but if it were equilateral, how would the angles be positioned? They'd be all the same, wouldn't they? If it were isosceles, what would be true about the angles? 2 would be the same. We don't have any angles the same. Therefore, what kind of triangle is this? Very good. It's a right scalene triangle. And that's the answer. Yeah. Will this be on the test? Yeah. 5. I think I understand this very well. I could do this problem well. Fortunately, it's going to be on the review packet in a few minutes. I'll have a chance to prove that. 3. Maybe with this notes and one more practice on the review, I can get through this. 1. This is that piece of my brain that never works. What do you think? Okay. All right, hands down. One more clarification. 5, the hardest part for me is the geometry. In other words, identifying that it's a triangle angle sum and adding them up to 180, and then finding out the measures and classifying based on that. 5 is, that's the hard part for me. 1, no, the hard part is the quadratics and solving for a quadratic. 3, they're both hard for me. Okay, a lot of algebra rough. Okay. All right. In the packet today, you will have a chance to practice this again. I want you to use this packet as a means of both practicing the skills, but also identifying where the gaps are. You've got a week between now and when we're actually taking the test. So you've got time to fix it, but it would help if you had some target, right? Ideas about what it is that you need to work on. So this is just simple classification to remind you. Here's some triangle angle sum work. This is going to be new for you. I want to clarify this for you. It asks you to use the corollaries of the triangle angle sum theorem. What does the triangle angle sum theorem say? What's true about all 3 angles in a triangle? They add to 180. That's all it says. So this is a corollary to that. And a corollary, like a tributary or something like that from a river, is a slight extension from it. So if we know that one of the angles in our triangle is 90 degrees or right, what do we know about the sum of the other 2? They add up to 90. They're complementary. Could that save you a step in the future? Sure, maybe. If you think about it as, oh, if this one's 90, these 2 have to add up to 90. Another corollary would be if angle 4 is an obtuse angle, what do you know about 3 and 5? Angle 3 and angle 5 both have to be acute because you can't have more than one obtuse. Both must be acute. And if you've got two triangles where one angle is the same, the second angle is the same, what do you think must be true about the third? Yeah, they got to be the same size, don't they? Because this one would be 180 minus these two, and this one would be 180 minus the same two. Angle 6 would have to be congruent to angle 7. Any questions on that? Okay, last piece I'm going to guide you through. This problem asks you to solve the problem in two ways. One is by using the linear pair theorem to find y. What does that mean? Debbie? Very good. So y plus 102 form a linear pair. Therefore, they're supplementary, which means they add up to 180. Subtract 102 and you get y is 78. Easy peasy. Then the second part says, then use the triangle angle sum to find x. So what would be asked of you there? Triangle angle sum would be where we say x plus 2. And now we found out that y is 78. Altogether equals 180. So 2x plus 80 equals 180. So 2x equals 100. That means x is equal to 50. Second part over here asks you to only use the remote interior angles theorem. What that says is y has to be 78, right? Because it plus 102 makes 180. But doesn't y also add with these two to make 180? So if this exterior angle is 102, what's the sum of these two angles?
$102.
It'd be 102, right? Because these two plus 78 make 180, just like this plus 78 makes 180. So what this remote interior angle theorem says is if you have two angles in a triangle, their sum is going to be equal to the remote, far away, exterior angle. Or it can be phrased as an exterior angle is equal to the sum of the two remote interior angles. So in this case, we'd say x plus 2 equals 102. 2x plus 2 is 102. 2x is 100, so x is 50. Okay, you have the rest of the period to work on this packet. Please use it as a diagnostic tool to help identify what you're good with and what you need to work on for the test 1 week from today.